Hi all, I am Dr. Shaini Paulin, Assistant Professor Mathematics, Department of Science and Humanities, Sri Muthukumaran Institute of Technology, Mangadu, Chennai. I am going to discuss about the topic non-deterministic and deterministic finite automata. First, we will see the definition of non-deterministic finite automata. It is defined by the quintuple Q, sigma, delta, Q naught, F. Q is the finite set of states. Sigma is the non-empty finite set of symbols called input alphabets. Delta is a transition function from Q cross sigma to power set of Q, and Q naught is the initial state. F is the subset of Q, which is final state. We will see an example. Set of states Q, we will have A, B, C, D, E and F, and the input alphabets A, B, C. Transition function is from Q cross sigma to power set Q. Let the initial state be A and final states are D, F. And this is the state diagram. From the initial state A, it accepts the input small a and goes to capital B and capital E states. And from B, it accepts small b as an input and goes to C. And C accepts small c and goes to capital D. Similarly, E accepts the input B and goes to F, and F accepts C and goes to E. And D and F are the final states. So we have two circles, and for A the initial state we have an arrow mark. Deterministic finite automata definition. It is defined as a collection of 5 tuples Q, sigma, delta, Q naught, F. Q is the set of states and sigma is the input symbol, Q naught is the initial state, and F is the subset of Q, which is final state, and delta transition is Q cross sigma to Q. DFA example. Let the set of states be Q0, Q1, Q2 and set of input symbol be 0, 1. Q0 is the initial state and Q2 is the final state. Here the transition function is Q cross sigma to Q. And the state diagram is Q0 accepts 0 and goes to Q0 itself, and Q0 accepts 1 as an input and goes to Q1. Q1 accepts 1 as input and goes to itself, and Q1 accepts 0 as an input and goes to Q2. Q2 accepts 0 and 1 as inputs and goes to itself. Here Q2 is the final state, so it has two circles. Transition table. It is basically a tabular representation of the transition function, and it is represented by the following things. Columns correspond to input symbols and rows correspond to states. Entries correspond to the next state. The start state is denoted by arrow and the final state is denoted by a star. Let us give the transition table for this state diagram. Here Q0 is the start state and Q3 is the final state. So it is represented with the arrow mark and Q3 is represented with a star. Q0 accepts 0 and goes to Q0. Q0 accepts 1 and goes to Q1. Q1 accepts 0 and goes to Q1. Q1 again accepts the input 0 and goes to Q2. Similarly, we will write for Q2 and Q3. Next, we will give the transition table for the DFA. Here Q0 accepts 0 and goes to Q1. Q0 accepts 1 and goes to Q2. The difference between DFA and NFA is DFA accepts every input only once. See, Q1 accepts 0 twice. It accepts 0 and goes to Q1, and again it accepts 0 and goes to Q2. We will design a finite automata for the input symbols 0, 1, which accepts only the input 1, 0, 1. Here Q0 is the start state and Q3 is the final state. Q1 accepts 1 and goes to Q1, and Q1 accepts 0 and goes to Q2. Q2 accepts 1 and goes to Q3. We will draw a DFA with 0 and 1 as input and accepts all the strings starting with 0. So the start state Q0 accepts 0 and goes to Q1, and Q1, the final state, accepts both 0 and 1 and goes to itself. But in DFA, every state should accept each input at least once. So Q0 should accept 1 as an input. So Q0 accepts 1 and goes to Q2, which is not a final state. NFA to DFA conversion. For a given NFA, we have to find a DFA. So for the given NFA, we will first write the transition table. We will construct a transition table showing all reachable states for every state for every input signal. The transition table is Q0 accepts 0 and goes to Q0, and Q0 accepts 1 and goes to Q1 and Q2. Q1 accepts 0 and goes to Q1 and Q2. Q1 accepts 1 as input and goes to Q2. Q2 accepts 0 and goes to Q0, Q1. Q2 accepts 1 and goes to Q1. So using this transition table, the set of states resulting from this constitutes a new state. Calculate all reachable states for every such state for every input signal. So from NFA, we are going to construct DFA transition table. The first initial state doesn't change. Q0 accepts 0 and goes to Q0. Q0 accepts 1 and goes to Q1, Q2. And here Q1, Q2 together is seen as single state. Now from the first column, we will have the Q1, Q2 as a new state, and it accepts 0 as an input and goes to Q0, Q1, Q2. Together, all these three are seen as single state. And Q1, Q2 accepts 1 and goes to Q1, Q2 itself. Next, Q0, Q1, Q2 will accept 0 as an input and goes to Q0, Q1, Q2, and it accepts 1 and goes to Q1, Q2. Using this DFA transition table, we will give the DFA state diagram, which is nothing but Q0 goes to Q1, Q2, and Q1 goes to Q1, Q2, Q2 goes to Q0, Q1, Q2. Here, since Q2 is the final state in NFA, all subsets having Q2 is considered as a final state. You can see that Q1, Q2 and Q0, Q1, Q2 are both having two circles which are final states, and Q0 is the start state. Thank you.